Hello, hello, hi. Okay, hi and welcome to the lecture. So in the previous lecture we had seen the idea of the convolution sum for discrete time signals and systems. In particular, if we have a discrete time system, x of n as and x of n is the input to the system. This is my system and I get my output y of n. Then we saw that the characteristic of the system can be completely understood by utilizing its impulse response. Essentially what that means is, if your x of n is your delta function, del of n, this is your del n axis, and if you give this as input to the system, you get a response y of n, which we term as h of n. H of n is the impulse response. So this is the impulse response of this particular system, that is the response to the unit impulse function. And the convolution, and if this system is linear and time invariant, we saw that the output to any input x of n can be written as y of n is equal to x of n convolved with h of n, where h of n is the unit impulse function, and this had the form x of k h of n minus k, k goes from minus infinity to plus infinity. So this was the convolution sum which we saw in the previous class. So essentially what this means, how this can be used in practice is, for example, now suppose let us draw the system, the input on this side, this is my input, again this is a delta function as input, and this delta function is giving me this particular output, which I call like this, 0 to let's say 1. This I'm calling h of n. So this is my input and this is my output. Okay, this is n. Okay, so note that this is actually a discrete time signal and a discrete time system, but just to make the drawing easier, I'm just drawing it as a continuous time system. The output, I'm drawing it as a continuous time output, but actually it is a discrete time output. Okay, so please keep that in mind. So this is my del of n and this is my h of n. This is the input and this is the output, which comes with when I give this as the input. So now if you look at this equation, what is this telling you here? So this, the left hand side is y of n. So that means for a particular value of n. Okay, so suppose you want to compute the output for a particular value of n, that particular value of the output is an infinite sum. Okay, so it is an infinite sum. The n here is coming only here. So essentially, if you have your h of n, which is this one, h of n minus k is nothing but a shifted version of h of n. And this xk here is the value of the function x of n at the particular value k. So essentially what this means is, because of the linear and time invariant properties, my output at a particular n is an infinite sum, where the sum consists of scaled and shifted values of the impulse response function. Okay, for example,